Hi, I'm Bob. Welcome back to 5 Minute Econometrics, a program focusing on fundamental econometric concepts, estimation methods, and identification strategies. We have learned the F-statistics, which is expressed in terms of the residual sum of squares. Today, we will derive the R-squared form of the F-statistic. The relationship between the residual sum of squares and the R-squared is as follows. R-squared is the proportion of the variation in the outcome variable that can be explained by the explanatory variables in the model. It equals the ratio of the explained sum of squares to the total sum of squares. Since the total sum of squares equals the explained sum of squares plus the residual sum of squares, we can replace the explained sum of squares with the total sum of squares minus the residual sum of squares. Equation 1 is the relationship between the R-squared and the residual sum of squares. After rearranging, we can write the residual sum of squares in terms of the R-squared and the total sum of squares. We plug it into the residual sum of squares form of the F-statistic and obtain the R-squared form of the F-statistic. Pay attention to the order of the R-squares in the numerator. The unrestricted R-squared comes first. The unrestricted model has more explanatory variables than the restricted model. Therefore, the unrestricted model can explain more variation in the outcome variable. In other words, the unrestricted R-squared is greater than the restricted R-squared. We use the example of the baseball players' salaries again. In the previous topic, we computed the residual sum of squares form of the F-statistic for the null hypothesis that the parameters of the three productivity variables are all zero. Once we include the years in major leagues and the average games played per year in the model. Now, let's calculate the R-squared form of the F-statistic. We first regress the unrestricted model, that is, the original model without any restriction. The eReturnList command enables us to find where the R-squared is stored. We generate a scalar equal to the R-squared. Next, we regress the restricted model, that is, the model in which the three exclusion restrictions are imposed. The restrictions are that the parameters of the three productivity variables are zero. So, the restricted model only has two explanatory variables. Make sure the sample size is the same as the unrestricted model. We also store the R-squared. Finally, we use the R-squared form formula to obtain the F-statistic, 9.55. It is identical to the residual sum of squares form. Because it is greater than the 1% critical value, 3.78, we reject the null hypothesis that all three productivity variables have no effect on salaries. In other words, they are jointly statistically significant at the 1% level. Today, we have learned the R-squared form of the F-statistic. Thank you so much for watching the video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.